Welcome people to the 44th tutorial, and in this tutorial we're simply going to be doing like weapon accuracy. So pretty much, yeah. So first thing is inside the gun class I'm going to change a few things first. So every single time we add a bullet, I'm going to create a function called release bullet. Yeah, void release bullet. And what I'm simply going to do is to see all this stuff. I'll simply call release bullet instead of doing this. So I'll remove this. I'll just copy it. I'll do that. And I'll remove this and put release bullet. Okay, there's nothing about that, so we can just continue. So instead of the release bullet, I'll simply paste this. So now, like, how's accuracy going to be working pretty much? If you go back to here, let me just remove the burst count. Let me reduce it to 2. Let's say you want to have different weapons with different accuracy, pretty much. You want to have different weapons with different accuracy, and yeah, to make it a bit more realistic. For example, like right now, if I do shoot, like, the gun's always accurate, and we want to be able to change that value. Okay, just ignore the rotation of the player. It's not that great, but yeah. So pretty much when you shoot is that we want, what's it called? We want it to be a bit fluctuating because there's recoil, and to simulate recoil and all that stuff. So yeah, to simulate recoil, we might also want to add, yeah. So I'll just create a simple float accuracy value. So we want to create accuracy for our weapons pretty much. Float accuracy is equal to, let's say, 100%. Okay, it's equal to 100. So what I will want to do is that after doing this, inside the release bullet function, inside here, I'll just need to work with the direction a bit. So yeah. And for that, what we need to do is to pretty much calculate the direction. We need to change the direction a bit. So yeah. What am I saying? Okay, whatever. So pretty much what I'm trying to say is, let me just open up Paint. Do you even have Paint? Yeah, I do have Paint. Wow. When you shoot a gun, let's say this is me. This is the player. When you shoot a gun, this is the bullet. It's going in this. This is, if you're shooting a gun in this direction, let's say, okay, whatever. You have, this is called your, what is it called? I just want to call this the, see this area that I've drawn in green? This should be like the area where your recoil can hit. Like, it's not always every single time when you're shooting this area, this direction. You don't want to be always, the bullets in real life won't always go like this. It won't always be like directly aiming at the object you're shooting at. There could be like recoil where the gun could go this way, the bullet could go that way. Pretty much you're trying to simulate accuracy. And this is usually a certain degree. This angle is usually a certain degree. Yeah. We're just simply gonna go with 30 degrees. Doesn't really matter. So this is pretty much, yeah, I don't even know what the fuck I'm saying. Pretty much, okay, what we're trying to do to create is like to simulate recoil, where when I aim the mouse here, I don't always shoot here. I want to be able to shoot this way and that way, just so that the gun, so that different guns have different abilities. Like you can have a gun that's long range but has poor accuracy, so it's better for short range combat, and you have a weapon that's for long range that has better accuracy, things like that. So yeah. So let's just go back to here. So I'll just create a float. I'll call it base angle, and I'll make it equal to 30. So base angle is equal to 30, pretty much this. So this whole thing is 30, which means this is either 15, this is 15 degrees and this is 15 degrees. Actually, let's make it 45. So that something more like this rather than something like this. This is fairly accurate. So yeah, let's make it 45. And what we want to do is that the closer this number is to 100, we want to make this base angle closer to 0. So how are we going to do that? I actually don't know. I'll just come back to you. So yeah, I thought about it real quickly. So we create something, we can have something like float spread. This is like the spread is equal to base angle minus base angle times accuracy and divide this by 100. What this means is that to make this number, because the higher this accuracy number, I want to make this angle smaller. And the base angle is 45. So what we want to do is to pretty much say 45 times accuracy, which is a percentage. Accuracy, whoa, what the fuck? Okay, so let's just do this. So this is the whole accuracy value. That will give me a percentage. So if this is 100%, that will mean that base angle is 45. So base angle minus base angle will give me what? It will give me something like 0. So I'll have a 0 spread. So now we have a spread. Now spread will be calculated to be an angle. So spread is pretty much an angle to rotate. So the new spread is more like this is the spread of a weapon, and this is the maximum trash accuracy you can have in your game. This is like the worst accuracy that you can have, and this over here is kind of like the spread that you have right now. So after calculating the spread, now what we need to do is to do actual rotating. Now I don't know how to do that, so I just went ahead and googled, and we get this rotating to the vector by angle. I'll just copy this and go here, and what I want to do is simply paste this. I'm a bit OCD, comment both of these, and yeah. So what we have is the new x component, blah blah blah, and all this stuff. By the way, one more thing is that with the spread, the spread value is currently only positive. We need to be able to make it positive or negative. That means is that what I'm trying to say, if the spread value is positive, that means only the accuracy will only be happening this way. If it spreads, it's going to be spreading towards this side. It won't be spreading this way. So we're just going to have to create a random value. So yeah, so I just call it so I'll simply say int value is equal to math.random. That'll give me a random value between 0 and 1. In fact, let me make this a double. This will give me a random value between 0 and 1. Now what I need to do is just to take away 0.5, and that will give me either positive or negative. That will give me either a positive or a negative value. So this will give me a random value, meaning that I can spread, so it can give me an either positive or a negative value randomly. So it means it can either spread upwards or downwards pretty much. And since we have our spread value, now we need to, change the spread value a bit because we want it to be random. We want to randomize it. So what we want to do, since this one gives times whatever, I want to say value is equal to value times 2. Not only that, and also want to multiply it by spread. Times by spread. Yeah, I can't really explain this, but pretty much this will give you random values, either positive values or negative values between positive spread and negative spread. I don't know if I'm making any sense. Pretty much what this does is it randomizes values between, let's say, for example, if our spread was 45, we'll be randomizing a number between 45 and minus 45, pretty much. So this will be our value, or angle, whatever. In fact, let me just rename it to double angle. So now we need to rotate. Goodness, now I need to rotate. Let me just copy this and redo all this stuff. Now we need to actually do the rotation. So in order to achieve that, I'll just do the same thing, copy and paste this thing, and just create float new nx for new x and ny for new y. So what it is simply saying nx is equal to old x times cos of the angle minus blah 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 blah. So pretty much saying it's old x. New x is equals to math x is equal to math dot, this say it is math dot cos. Okay, math dot cos what angle? Cos angle, which is going to be this angle, times the old x, and we're going to multiply the old x times direction dot x Wait, do we actually have a rotate function in the vector class? I don't know. We could have a rotate. Do we have a rotate? Nope, we don't. Wow. First of all, no, actually, first of all, we need to normalize the direction. Direction.normalize. Direction. So we need to first normalize the direction, otherwise this won't work. Yeah. So new x equals to math dot equals this direction dot x and what? Actually, let me just rename this to double. So times cos of the angle, which is this part, and then we need to take away old y minus sin. Okay. And we take away math dot sine angle times old y. And instead of using direction, we want to use normalized direction. Direction dot y. And we're just gonna copy the same thing, and okay, it's not gonna be the same thing, but something similar for the y as well. So this one will be alt x, okay, alt x times sine of the angle. So instead of cos, I'll simply rename this to sine, and plus old x to old y dot cos, and we'll simply say dot cos. And I think we're good to go. Okay, we're almost good to go. It's just that here for the direction, we simply need to pass in new vector 2 and pass in nx and ny. Okay, why is this giving me an error? Oh, okay, so we need to cast this to floats. And I believe we're good to go. So now when we test this, wow, the accuracy. Okay, I think we just broke this thing. So So guys, after aeons of figuring out what was the problem was that when I copied and pasted this, I left this as a minus, while the formula says it needs to be a plus. So yeah, that was the major problem. So we do that. And the other problem is that when we're rotating using angles, we need to convert the angles to radians, because that's how the cos and sine libraries work. So we can go ahead and remove this and remove this, and actually need to put this multiply by 2 back there. And it took a lot of debugging to figure that out. So anyway, so when we run this now, you can see the accuracy thing is working. So now here we're sitting at 10% accuracy. Let's boost this up to 50%. As you can see, it's slightly more accurate. And let's boost this to like, I don't know, 80% accuracy. As you can see, it's just a bit better. The accuracy has improved a bit, and we can boost this to 100%. And as you can see, the accuracy is epic. So yeah, guys, so that's how you do accuracies in the game, how to implement accuracy pretty much. And yeah, that's it, guys. And also, wait, before we go, one thing that I want to do is to go to vector f. I want to add the rotate function directly into the vector f. It looks like a useful function to have. So simply say public vector to f rotate, and we're simply going to be taking as number one, we're going to take in the angles, the angle, double angle, rotate, angle. And we're going to simply say return, rotate, radian, rotate rad, double. I'm going to pass in this angle. And here I'll simply have and instead of simply going to say math.to radians angle, and yeah, here I'll simply have public void, no, not void, vector 2f rotate angle radians rotate rad So here I'll simply say double x, y, return new vector 2f, xy, and casting this into a float, same as this, and we just need to go back here into the gun.java, and we want to copy this. I'm just going to change this. change this to radians. Change this, oh my goodness. And we want to change this to x and y. And I want to change this to normalized direction. We're simply going to say normalized. And I think we're good to go. Now we can simply go into gun, and instead of using all this stuff, I can simply say, I can simply remove all of this and simply say vector dir is equal to direction dot rotate radians. In fact, we don't need to calculate, we don't need the radians, we can actually say rotate angle. So direction is equal to direction dot rotate angle, and simply going to use this. And yeah, it looks a lot nicer right now. Okay, to make sure that it's working, let's change up the accuracy to 10 and let's run it. Okay, let's see, it's all good. And let's make the base angle 45. Yeah. So that's it. That's it for the video, guys. So if you liked the video and you enjoyed, press the thumbs up. Yeah, I did not expect it to take that long. Wow. Okay. So yeah, guys, if you liked the video, hit the thumbs up, and yeah. Peace.